Welcome everyone. Welcome to this particular lecture of thermoelectric transducer. What is a thermoelectric transducer? It will convert the temperature to the electrical signal or electrical signal to temperature. So this thermoelectric transducer that we will be mainly studying here, they are classified into two types. One is thermistor. So if there is a change in the temperature, there will be change in the resistance. Okay, if you can measure the change in the resistance, you can measure how much is the change in the temperature. Then another thermoelectric transducer is a thermocouple. They will convert the thermal potential difference into the electrical potential difference. So first we will see the thermistor. Thermistor is a resistor or sensor. Its resistance changes with changing temperature. It is also known as a thermal resistor. Since the resistor fluctuate their resistance with temperature, but thermistor is a specially designed thermal resistor. It is a passive component that is used in electronic and electrical circuit. So you can see there are different types of thermistors shown. How this thermistor is prepared, like it is fabricated. We take the powder form, semiconductor material in powder form. Then with some binder, we make a paste of this semiconductor material, which is called the slurry. Okay. Then on the lead wire, we pour a drop of this slurry. Okay. Then it is dried in a furnace, sintering furnace we use to dry this slurry. Okay. So this is how these thermistors are made. On this slurry, sometimes when it is dried up, we put a glass coating so that it can serve as the waterproof thermistor. Okay, so thermistors, they come in different sizes and shapes. In bead type thermistor, it is the smallest thermistor. The diameter of this bead type thermistor is 0.15 millimeter to 1.5 millimeter. Then we have rod type thermistor, we have disc type thermistor also. So this is the symbol of the thermistor. In thermistor, what happens? Whenever there is a change in the temperature, there will be the change in the resistance. Now, there are two types of thermistor. One is the negative temperature coefficient or NTC. In this case, in this case, the temperature and the resistance are inversely proportional. Okay, that means when we are reducing the temperature, the resistance of the thermistor will increase if it is a negative temperature coefficient or NTC thermistor. Next, if we have a positive temperature coefficient or PTC thermistor. So in this case, what will happen? When the temperature increases, the resistance will increase. When the temperature decreases, the resistance will decrease. So that's what happens in the PTC thermistor. So what is a thermocouple? So thermocouple, it is a measuring device which is used to measure the temperature of particular portion. It works on the principle of temperature difference between the two junctions. So there are different types of thermocouple that is designed according to the applications. We have different types of thermocouples. I have listed down a few. These thermocouples are based on the materials we use. Okay. So in thermocouple, what happens? We take two different materials. Let's see. There is one material and this is another material. One is iron and another one is a iron lead and another one is a constant and lead. Okay, now we have the point at which we are joining the two materials, that is called the junction. So here is one junction and here is one junction. Now if we create a temperature difference between the two junctions, let's say this is the cold junction and let us say this is the reference junction. And how will you make the hot junction? You can use a candle for that. So as per Seebeck effect, it tells that if we can create a temperature difference between the two junctions, between two dissimilar materials, then there will be a voltage difference created across these two junctions, and we can measure the voltage difference by using a voltmeter. So as a result, a small current will start flowing through the thermocouple. So this is what Seebeck effect. What is Peltier effect? It is just opposite to the Seebeck effect. It tells that if we can create a voltage difference between these two junctions of two dissimilar materials, then there will be a temperature difference created between the two junctions. That is the Peltier effect. Now, uh, we have different types of thermocouples based on the different metals we are using. So in type K thermocouple, it is the most commonly used thermocouple and it is mostly expensive thermocouple. So here we use 90% nickel, 10% copper as one material, and then 95% nickel, 2% aluminium, 2% manganese, and 1% silicon as another material. And here the temperature range we keep between minus 200 degree centigrade to 1260 degree centigrade. Now type J thermocouple, it is a thermocouple which is less in price but most commonly used thermocouple. Here the two materials are, one is iron, another one is the 40 constantan, which is 45% nickel and 55% copper. Here the temperature range is minus 210 degree Celsius to 750 degree Celsius. Next is type E thermocouple. They have higher accuracy and stronger than previous type K and type J type thermocouple. Here one material is a 90% nickel and 10% chromium. Another material is constantan. Then in constantan we have the 95% nickel, 2% aluminium and 2% manganese. So the temperature ranges between minus 270 degrees Celsius to 870 degrees Celsius. Next in type N thermocouple, this thermocouple is designed by the Defence Science and Technology Organization or DSTO of Australia. So the accuracy and temperature limit of this type N type thermocouple, it is same as the type K type thermocouple. Here the materials are nitrosyl, which is the combination of nickel, chromium and silicon, and nisyl, which is the combination of nickel and silicon. Temperature range is minus 200 degrees Celsius to 1260 degree Celsius. Next type B thermocouple. This type of thermocouple, it is made up of the platinum and rhodium and it is used for high temperature applications. So what are the materials used in type B thermocouple? One is 70% platinum and 13% rhodium. Another one is like full 100% platinum. So the temperature range is up to 1800 degree Celsius.